So you and your family, you're going to end up investing $1,000, okay? And you have two choices. You can do a bond, and there's a table with what happens with the bond. Also, some context above. And then there's a savings account. One thing about the savings account is it costs $20 to open it up, and you get 2% interest each year, okay? 2% a year. Both options pay out annually, so that's important. You're not splitting that 2% up into quarters or months, all right? And you can see a progression from your table. It's your job. I'm going to come back to this slide, but it's your job to answer 1 through 4 here. We'll look at 5 together with your partner. So you're going to say, explain how they grow, okay? Then you're going to write the function for each, and then you're going to make a choice. Which one should your family invest in and why? Then we'll look at the graphs together. So 1 through 4 here with your partner. Get after it. I would do the table first. Do the table first.
All right.
Eyes up here. Mouths closed. We're going to start with the bonds. That one's a little just generally easier. When it says simple interest 2% a year, that's meaning 2% of the $1,000 is what happens each year. So that's another way to say that would be $20 per year. I'm just going to choose to go years 5 and 10 for my inputs on my tables. Okay? So at 5 years, $20 a year, I'm going to earn how much total? Nobody's got it? One. Okay. And at 10 years, $1,200. It's $20 a year. So let's write the function for this. I want to say the bond is equal to the 1,000 I start with plus 20 per year. That plus looks kind of not like a plus. Okay, there we go. Everybody see my bonds and what's happening with my bonds? Okay. 1,000 plus 20x. For my savings, this is growing by 20% compounds or 2% compounds, so it's changing each year. Okay, so from year to year, my factor I'm multiplying by is 1.02. To get these next two, I'm going to choose to write the function first, which you have to do anyway in your notes. And I'm going to say my savings is equal. How much is starting in my savings?
980.
980. What's happening to it?
Times 1.02.
1.02 is my growth factor. So for 5 years, I'm going to do 980 times 1.02 to the fifth. It's going to be somewhere around 1,082. It's going to round to $1,082. And then we'll do the same thing for 10 years. So instead of compounding 5 times, I'm going to do 10 times. I'm going to be at 1,194.61. All right. So we took care of question 1 and 2, I believe. This one's increasing by $20 per year every year. This one's increasing by 2% each year. The next question is, which one's growing faster?
The same.
This one grew by 20 to start, and this one didn't. So which one starts faster?
Bonds.
The bond started a little faster, but what's catching up?
Savings.
Savings. And over time, what's going to happen, do you think?
Savings.
Savings going to overtake and then be gone, right? We know how an exponential function works these days. So that might take a couple sentences in your notes to explain, right? So the bonds start a little quicker. Savings are exponential, so over time it's increasing more and more. It'll definitely overtake it. The next question is, and there's kind of 2 right answers, which one should we invest in?
Savings. Well,
Some people are saving savings.
It depends on how many years you're going to do it.
Yeah,
It depends how
so
old you are.
if we knew when they're equal, which we're going to do in a moment, we would say the lower time is better for which one?
Bonds.
Yeah, this is better for less time. And if we can go like long, which one's going to end up definitely being better?
Savings.
So if this is long term,
After 100 years, savings is $4,000.
savings is $4,000 more after 100 years. What we got? So because the exponential catches up, it'll just zoom right past the linear. The linear just keeps going 20, 20, 20, 20. I wish they would have done 21, because then you can sound cool saying 21 over and over. All right, test.
You have done like 103 forms or 5
Yeah, you could have done other inputs. I just chose 510 for my open inputs. Yep. So let's go look at the decimals together.
Oh, we need a
Nope. That's why together I'll do it on my laptop, from my desktop, looking at it through my iPad. And let's write the 2 functions here. The first function is we start with $1,000 and we're adding 20 each year. In the second one, we start with $980. We're increasing it by 2% each year. And you're like, hey, Mr. Mack, we can't see it. Yeah, because we're starting like near 1,000. Now, we're not starting at 0. So I'm going to make my y-intercept the lowest. Let's go. I need 980. Let's go 950. All the way up to 2,000. All right. And my x, we don't need negative years. Let's go 0 to 20 years. Let's see what's up. Yeah, I like this view. Okay. So, where on this graph would I look to see whether they're the same?
11.
Where they cross, right? It looks like 11.354 years they'll be the same. So if we wanted to tighten up that last question, if it was 11 years or less, we would want to put in savings or bonds. Which one? Bonds. If it was more than 11 years, we would want to put in savings. That because it's happening once a year, right? And then look at, as we zoom out, savings, what happens to the gap between savings and bonds? Wider and wider, because this is a percentage. 2% of a big thing is a bigger thing, and 2% of that bigger thing is a bigger thing. And 2% of the bigger thing is a bigger thing. The line's just 20 each year, right? Cool? I think
How high does it look at 200?
200 years? In 200 years, you can turn your 1,000 into 50,000. Ooh, time is money. I've heard that said before. I've heard that stated before. Yeah, that's why money can pass generations if it's... Yeah, we did that one. Okay, next up. This is on the back side of your notes. There's two functions here. We've got f of x and g of x. It's your job to explain what's happening in the function. Okay, we don't have context, so you'd have to explain like just generally. And then which one is going to get to 2,000 first, and how do you know? There's a suggestion in your notes for guessing and checking that. We do not have the skill set to isolate a variable if we set these equal to each other.
Wait, where is that?
On the back of your notes, everybody. All right, who can explain to me what's happening with the f of x? What's going on there over and over and over, Ellie? It's doubling x, which I'm leery of the word double because that's exponential. So it's up to for each 1x. So if my table went 1, 2, 3, 4, I'd get 2 more each time. 2, 4, 6, 8. It's adding 2 over and over. So this is what type of function? Linear. And the 2 in that linear context is my what? Slope. 2 is the slope. What's my y-intercept of f of x equals 2x? 0. If I put 0 in for x, what's 2 times 0? 0. My y-intercept is 0. Looking at g of x, what kind of function do I have there?
Exponential.
This one's exponential. And it's showing what?
1% increase.
1% increase, not to be confused with the 1.01 growth factor. Why is there actually 100% in the growth factor?
Because if there wasn't, then it'd be decreasing back to
Yeah, 100% is how much change? None. No change from the 100%. The 100% keeps it. What's the y-intercept of g of x? This one's a little trickier. It has to be 1.
1.0.
It's right here. It's 1. Don't you see it? Here's how we know it's not a 0. If I multiply 0 by 1.01, no matter how many times it's 0, you can't have 0 for an exponential, right? You just get 0. It'd just be 0. Yep.
It's just a straight line on the 0.
Yep. So that's what's happening.
Wait, so the intercept is 1?
Yeah. It has to be 1.
Oh, yeah.
Also,
Yeah.
you're going to raise to the exponent first, too, right? So 1 times stuff is always that stuff. Which is going to reach 2,000 first, do you think? Or is it G of X? So I think I tested 700 and then 800. Let's do that right now. F of 700,
I did that too.
F of 800, and I did G of 700 and G of 800. Let's see what we get. Okay, there's a little too much side conversation for my liking right now, so let's fix that. So that's 1,400 and 1,600, so these ones aren't there yet. So I go to G of X, got 1.01 to the 700. I got 1,059, 16. That's not enough. So I went to 800, and I got 286483. So if at 700 it wasn't enough, I was guessing that one's getting there first, G of X. Which one grew faster to start? Yeah, because 1% of 1 isn't much, is it? So f of x was growing 2, 4, 6, 8. Take a while to catch up. But then once g catches up, bye-bye. Right? Way more. I like it says, bye-bye. There's the table you could have used. We kind of already talked about all that. I'm going to choose to skip the summary today because I felt like you were vibing. But I do want to show you something quick from yesterday.